Uh, nice of you all to join this workshop on cloud-enabled additive manufacturing. This is a kind of a great gathering because many of these people who give technology-oriented workshops on cloud or additive do not have the right people to give, whereas we have now aligned you with the right people available across the globe. We have people from Oracle, we have people from SAP, we have people from Larsen & Toubro, we have from the academics, we have additive manufacturing company talking about the machine and the process. We have a lot of things which is a unique a specialty of deliverable, which this group of people are being having a kind of a palette in front of them to be served with. To start with, let me put put the screen on speaker view so that we see each other as we talk. See, today we are going to have people from the first speaker is going to be from Oracle, Kandaswamy Umapathy. I'll just read out his specializations and experience so that you can understand what kind of a delivery you can expect from him. Senior software development leader with extensive experience in leading cross-functional teams in the execution of DevOps projects, highly skilled in hosting applications and technology products in private, public, and hybrid cloud models. As part of the HCM software development organization, his team was responsible for software lifecycle activities, performance tuning, data integration, data quality of large-scale HCM public cloud. To know his specialties, he is the expert from Oracle on cloud computing, high availability, enterprise applications, multi-tenant database systems, data integration, and building leading global organizations. Now I leave the floor open to Mr. Kandaswamy Umapathy. Floor is open to you, sir. Please start.
Thank you, Dr. Krishnan, for the kind words. I'm not sure how much of that is all.
No, you deserve more.
Okay. So anyway, so I can get started, right?
Yes.
Okay. So let me first share my screen. Okay. Can you confirm?
Yeah, it is opening.
Okay. And is it good or you want?
No, you need to presentation mode. Yeah, please.
Okay. Just give me one more minute. Sorry. Okay. Hello, everyone. My name is Kandaswamy Umapathy. I manage the Human Capital Management Cloud at Oracle public cloud offering. So I'm not a manufacturing expert, and I see that there are a lot of manufacturing experts out there. They can cover manufacturing aspects of this in detail. What I'm going to do today is covering the cloud technologies, right? And then also I'll briefly touch on what are the manufacturing cloud offerings that different vendors have out in the industry. Okay, what is cloud computing, right? So this is for the ones who are not familiar with the cloud. Nowadays, everyone is using the cloud, irrespective of whether they consciously chose to use it or. Dr. Krishnan.
Yes, please.
So there is a background noise. I'm not sure. Is that an echo or?
Maybe an echo only.
Okay.
From your system.
I think if we can mute others.
Okay. I'll do it. Mute is between you and me. Okay, let me mute myself.
Yeah, I think it's okay now. Sorry, I'm still having. No. If we can mute everyone, that'll be good. I'm still hearing the echo. Okay, I think it's good now. Okay, so a virtualized pool of resources. These resources can be anything starting at hardware, right? Compute,
Sir,
can you
we
hear me
can't
now?
hear you.
Yeah,
Ah,
yeah.
yeah, yeah. I think you muted yourself. Now we can hear you. Yeah.
Okay, that's good. So virtualized pool of resources, right? So there are two keywords here, the virtualized and then the resources, right? The resources can be hardware or software, like it can be compute, storage network, or it can be any type of software, monitoring, content management, collaboration, communication, financials, human capital management, manufacturing, supply chain, CRM, whatever applications out there in the world, right? So then comes the keyword we have is the virtualized. So these resources should be virtualized and shared with multiple customers. So that's kind of a key that drives the pricing on these cloud solutions. So it has to be a virtualized pool and pool of resources. The resources can be software, hardware. When we move to manufacturing side of it, it can be anything. I mean, it need not be these hardware and software in terms of computers, right? So we'll come to that a bit later. Available on demand. So this is something like as some of you are aware of this Elastic Cloud, where if I buy one TB storage and tomorrow my requirement changes, and then I'm going for one um, you know 100 terabytes of storage, then I should be able to get it just like that, in the pay as you use model. So the pay as you use model is not something new, right? So we have been using, so this is also called utility computing, right? The reason why they call utility computing is pay as you use, like our electricity usage, right? So we don't buy a generator to generate our electricity. We subscribe to a service, and then whatever amount of electricity we use, like we pay. So the same concept here, like it can be compute or storage or both of them, network, dedicated, shared, whatever you want, right? So based on how much you use, you will be billed at the end. So that's the pay as you use model. Obviously, this feature of the cloud reduces the capex expenses, right? So the capital expenditure goes down. So you don't have to put in a lot of money to get onto cloud. You can just get on and then pay as you use, right? And also the operational cost. Operational cost goes to the vendors, right? So they operate, they manage. So you just pay for both the use and then for the maintenance as well. So I still remember I used to do the coding several years back. Whenever there is a bug in our code, when we get a ticket from the customer, the first thing that we ask is what is the version on which they are there, right? So depending on that, we will tell, you need to take the next version to get the fix, and so on, right? So this headache is not there in the cloud because the operations are done at the vendor side, or cloud provider side, right? So without even we knowing about it. So most of you might have seen, it's all getting done with the zero downtime, or with some amount of downtime. Very, very simple applications like communication software and things like that. We don't even know when they are updating it. So it's all like, next time when you go and use the software or hardware, it's all updated already, right? So we don't even know when that was done. So the headache is not for the consumers. The headache is for the cloud providers. And the last definition is amorphous, right? The cloud is amorphous, meaning there is no clear boundary on this, right? So that's good. Like, each one of us today itself is going to give a different version of what is cloud computing, right? That's the beauty of cloud computing. So as long as it meets some of these criteria, like, the resources are virtualized, and then sharing of resources happens, and then it's available on demand, and the pricing model is based on the metering, pay as you use. As long as it meets some of these criteria, you can call anything as cloud. Okay. Okay. So we have different models of cloud computing. By deployment, we have some categories depending on who manages what. By service, we have different categories as well. So private cloud operated solely for a single organization, maybe on-premise or off-premise. So this is where you are still not ready to go onto the cloud, but you want to leverage the benefits of the cloud. You stay private, meaning either you get everything on the cloud, but it is dedicated to you. Nobody's sharing any of the resources in the stack. Like, you don't have a shared network, you don't have a shared storage, servers or software. None of them are shared, and they're all dedicated to you. And either this can be located in your data center, or it can be on the vendor's data center. So you still get the benefits of the maintenance being done by the vendors, and also the cost is going to be less because they're not going to be maintaining different versions, and still the security you get from a private cloud, you get that as well. So the community cloud is in between the private cloud and the public cloud, where sharing of these resources happens for a specific purpose, right? So it may be a government cloud, or for regulations related and things like that. You can group certain customers who are in the same regulation, or you can group some customers who are in the same government agency, right? So that's the kind of community cloud. It can also be on-premise, or it can be off-premise. So that's the community cloud. And public cloud is the big one. That is the one that everybody is talking about. It's available to a general public. As long as you have a valid credit card, you can go out to cloud and subscribe to a service, right? So this cloud is owned by a single organization. Like AWS is owned by um, um, Amazon and Azure, Microsoft, and OPC, Oracle, and there are a lot of vendors that provide these public clouds, and it's completely owned by them, and you are subscribing to a service on it, right? That's public cloud. Now, um, the current model that's happening is mostly on the hybrid cloud. So people are not ready to go on to a public cloud yet. So what they do is they slowly move non-critical, low latency workloads to public cloud, and then keep more secure, critical, high latency applications on premise or a private cloud. So a mix of any of these private, community, public cloud is called hybrid cloud. So by service, so who manages what, right? The legacy systems that we have, it's called package software, right? You go and pay, and then you get a big software bundle, a bunch of CDs. You go and install them and start using them. So that's the package software. So that's how we had been doing all along, and now that is changing. It can change a little bit or completely, right? So as we go from infrastructure as service to platform and to the software as service, the amount of the hardware and software that's managed by the cloud provider increases. So if you take an example of this infrastructure as a service, so the networking, storage, servers, virtualization, all of these are done by the cloud providers, and whatever operating system you want to install on top of it, middleware, and then runtime and databases and then applications, it's all you managed. You may be building them and then using it, or you may be buying it from another vendor and putting it on. You may have an Azure networking, storage, servers, virtualization, and then put your own operating system on top of that, the applications that you built, and put them on that. So that's the infrastructure as a service. There are a lot of players out there, Azure, AWS, and OPC from Oracle as well. So the next one is platform as service. I just want to manage my data and application. I want the remaining software piece managed by the vendors as well. So you leave the operating system, middleware, and runtime to the cloud providers as well. And then you build your own application and manage that on top of that. So that's the platform as service. The last one should read as software as a service. So this is where the entire stack is managed by the vendor. So right from the networking to the applications, it's managed by vendor. All you need to do is do a little bit of customization. I would strongly recommend not to do customizations. It's like, we used to do all this um, the clothing done by the tailors, right, in the past. So we make sure, like, it's all fitting to us in all aspects. I'm sorry. But nowadays we don't do that. Like, we go and buy based on our size, small, extra small, medium, large, right? So we buy like the standard ones and we start using it. It may not exactly fit us, but it's kind of meets most of our requirements. So I would strongly suggest, like, we use the standard offerings from the customers. If you do more customization, and then you'll get stuck with the vendor, and then vendor lock-in will happen, and all the benefits of moving the workloads from one place to another, or that will reduce significantly. So. Okay, so we have two more terminologies, the multi-cloud and the poly-cloud, right? So what is multi-cloud? Now, use of multiple cloud computing services. Why are we doing that? Why we are not using a single vendor, going for multiple vendors? To reduce a reliance on single vendor. So we don't want to get locked into a vendor. And also it gives more flexibility. So let's say, like, there is some problem with a vendor, and then we can easily start using the other vendor because we are already using them, right? And it has to be in a single heterogeneous architecture. So you cannot, in multi-cloud, you cannot mix two different, let's say, like, one running on Linux, the other one is running on Windows, or one running communication software, the other one is running some content management software. We cannot mix things like that. So Disaster mitigation also happens with this multi-cloud model. Like, if there is a disaster, what you can do is you can completely move to the other vendor. That is a vendor two. So let's say like you're using Microsoft Azure and um, um, Salesforce, right? So what you can do is something happens on Azure, you can move to Salesforce, Salesforce to Microsoft. So you can have that disaster mitigation like that. So the good example of this multi-cloud, and it did happen, and I have first-hand information on that, is the Zoom call that we are using right now. Zoom used to run on AWS. What happened during the COVID pandemic is like the Zoom usage increased like anything, like it went up by 160%. So they were not able to scale to that extent with the AWS. Then they had to choose two other vendors. One is the Microsoft Azure, the other one is the Oracle public cloud offering, or Oracle Cloud Infrastructure, they call OCI. So they moved on to these two. I mean, they did not completely move off. They chose um, two other vendors, and then started routing some of the Zoom calls through Azure, some of the Zoom calls through OPC, some of the Zoom calls on the Microsoft. So so it has to be heterogeneous, because Zoom is Zoom. Like, you send, 10 calls through this and another 10 calls through other one. So it has to be heterogeneous. It cannot be um, a different services, right? So that is the multi-cloud. So coming to the polycloud, use of multiple clouds, even here we are using multiple clouds, but we are leveraging specific services that each provider offers. So if you look at like here, like we have a lot of providers listed out here. I may like the HP hardware, so I can have the HP hardware, and then I may like a SAP ERP or Oracle database, Microsoft Office 365. So I can kind of mix, but take best of best. So, it's um, um, it's kind of a mixing of services, choose best of best. And but this is not for flexibility. So in the multi-cloud, the flexibility, right? Zoom, you can you can route it through several, but here it's not the case. So if you choose HP for the hardware, and you can only rely on the HP for the hardware, right? And then if you choose Oracle as the database, you can only send your database workloads to the Oracle database. So this is not for flexibility. This is to get the best of best from the vendors. And also this is not for disaster recovery. So you cannot, take the load on the hardware and then transfer it on the database, right? So that doesn't match. So the polycloud, there are a lot of people, like I know one of the Swiss bank, and almost like they have 5, 6 cloud vendors in hybrid model also. So the more complication comes in when you do like some of them private from some vendors, right? So you have a private cloud on HP, and you build your own software, and then you're running more secure things here. You see this arrow here, right? So if you want more control, more specialization, more security, and then you go private, and these are the vendors, they give the private cloud. So on the right side, so you see if you want more agility, like, you get the versions just like that upgraded, right? And then if you want to expand, you started a startup with 10 employees, and then you go 100 employees, and you go 1,000 employees, you go 1,000,000 employees. You can keep on expanding. It gives that elasticity. And then all these vendors here, they all provide um, um, that kind of offering. And also massive scalability that I was talking about. So elasticity and massive scalability are the two keys where you want to go for public cloud. Okay, so then comes some special clouds, right? So these are like edge and fog computing, right? So it's not new. We had been talking about distributed computing for a long time. So here what happens is you are moving the workloads. So you have cloud and then you have edge. So you have servers and storage, and then you have edge where you have copies of that or closer to the customer, right? So you have the edge nodes. So why do we have this? So we have this because we are bringing the computation and data storage closer to the sources of the data, right? So especially like, if your application, your requirement has a lot of IoT type of input that is coming in, then it's much better to do it at the edge because of the very low latency requirements of these IoT applications. So we need another layer where we can do all the computations and sync up periodically with the cloud, right? So basically the improves response time and the use cases IoT applications. Now, what is fog, right? So in a lot of places you will see like, hey, edge and fog are used loosely, right? Some say like, edge and fog are same. However, there are some variations to that. The same edge nodes can serve as fog, um, and they can do some filtering and then sending it back to the cloud, right? So fog servers can sit on the edge nodes and they can do further filtering before sending it back to cloud, right? Otherwise, sometimes they call the edge as the fog as well. So don't get confused. Basically, where can you see this? Where can you see this? So, for example, you may be already doing it with Netflix, right? The content delivery network, right? CDN. So these content delivery ones, like they all cache it here. You might have heard about the company called Akamai, and they had been doing this edge computing before even it was called edge, right? So it has a lot of benefits in manufacturing too. We have a lot of IoT devices that are sending data. So you don't want to send it all the way to the cloud and then do the computation because you need to quickly react and take the corrective measures. So you better cache it in the edge, and then you can quickly respond to those alerts and events. Okay, this is another specialized one. And in the early stages, the big data was not going to cloud because the big data will sit on premise, and the actual data will be in the cloud. So more and more data are getting generated on the cloud. Now they decided to put the big data also on the cloud, right? So that is because it's possible to transfer large amount of data. Now the data originates in the cloud itself. So the data that originates in the cloud, you pull it into the big data system, and there are a lot of bare metal servers availabilities, high performance are available. So that's making big data on the cloud possible. So you can use this for business analytics, geospatial analysis, and here the key is volume, right? So they call triple V. Um, One is the volume, and the other one is velocity at which the data should be given back. And then the value of the data as well. So that's where the analysis part of it coming, and it is extracting the value, and then high performing storage and network is enabling the velocity at which it can give the decisions back. So um, this is a specialized um, cloud as well. Cloud security, one of the reason why people say like, hey, I don't want to go to the cloud is the security, right? So we talked about latency issues, and the latency issues are now coming down because we are moving into 5G and things like that, and that is going to solve the problem of latency. But cloud security is still a problem. And so there are a lot of specialized things that are out there to control this. But if you ask me personally, um, the cloud vendors, there are big vendors, right? So they manage thousands and thousands and thousands of customers on their cloud, right? So they know these security mandate from the government agencies, and then financial institutions, and a lot of customers they are supporting. So they get a superset of all the security requirements from all the customers. They build the systems based on that, and also they give us specialized services for some. Some may need a specific type of encryption. Some of them may need a demilitarized zones and DMZs and firewalls and whatnot, right? So what they do is they take the superset, which is from all these customers, that they build a security model, right? Either that's by standard you get it, or you may have to pay a little extra to get those. So I would say, like, if you're running your own data center, you're putting your own applications on it and then running it, you to get all the security requirements met, you may be spending lots and lots of money on it, right? So the different dimensions of this security, deterrent control, like
Kandaswamy, 1 second, sorry to interrupt. We are running out of time. Huh? So,
okay.
Yeah.
So you want me to conclude now, or?
As quick as possible, because it'll others time will go off.
Okay.
All right.
So okay, I will skip. Yeah, security. So you know that security is important, right? Like that. So you need to evaluate security before you get onto the cloud. Okay, on the manufacturing, it's an end-to-end ecosystem. So earlier it used to be done in bits and pieces, some of the design software out there for manufacturing, and there are some production softwares and management softwares out there. But today we have the entire ecosystem supported on the cloud. So what are the challenges in the manufacturing industry? So I wanted to go one by one, how cloud is solving those problems, but you can ping me offline if you have any questions on how is cloud solving these problems, right? Skilled labor shortage, supply chain instability, smart factory, cybersecurity, direct selling. More and more customers are going e-commerce and buying products, and then personalization. So you want to customize your shoes and shirts and things like that. So how is cloud solving that problem? And scaling the manufacturing. Like, I gave an example of, you have a startup and then you're doing 10 users, and then 100 users, and the later 1,000 users, and when to scale. With the elastic cloud, that scaling becomes completely transparent. Okay, so you have several softwares that are put in place. um, you can leverage. You can go with all of them or some of them. manufacturing execution system softwares and ERP software. And then ERP is the kind of central hub for all of these, right? And then the entire product lifecycle management software. And then we have monitoring and maintenance system software, and then customer relationship management software. So you have all of them there, and there is a overlap of these applications as well out there. And there was a market study done, and how much of that is already on the cloud, and then how much is on the on-premise, and how much is on migration for next 2 years. So if you look at the ERP is already 50% of the ERPs on the cloud, and then the PLM 50% is on the cloud, and then the others, monitoring, maintenance, and the execution, they're all slowly moving to the cloud as well. So cloud is the direction, and if you haven't planned already, plan for it, and then encourage others to move there as well. All of the latency and security issues are being worked out, and it's a lot better than how it started 15, 20 years. Okay, so more and more things are getting converged, ERP and MES systems, and then IoT and MES systems, and all of them, right? So some of these vendors from vendors like SAP or Oracle, they have all of these suites in one big software, right? CRM, ERP, MES, and operations management and supply chain planning, all of them put together in one suite of software, right? And AI and ML, a lot of people are providing this as a standalone service. Like you have AI and ML platform, and you can go and build your own on top of that. But they are getting embedded into the ERP systems as well. So you will get embedded AI, embedded ML, and then digital twin and IoT technologies are getting embedded as well. So you can either go for the platforms for these, like a digital twin, IoT, and AI, and things like that, or you can leverage the ones that are coming. Like they already hired all these data analysts and then built those systems. They're providing them as a library, or it's all embedded. When you buy with that option, it will automatically start giving recommendations. Okay, I want to do this demo for 2 minutes. I don't know. I'll come back. Okay, just to give the market share of each of the softwares that we were talking about. If you're interested, you can go through and then see how much share is owned by each vendor in each of these areas. Okay. Outlook, how is it looking like? Business and shop floor software that are non-critical and non-real time are moving. So it says we'll lead the migration, but it's already leading and it's out there. And shop floor level logic operations will take longer to move. New developments like 5G and wireless communication will address some of these latency issues that impact real-time applications. In combination with the new technologies like artificial intelligence, digital twins, IoT, so the cloud is going to be indispensable and will improve manufacturing operations. So roll up the sleeves, bite the bullet, pull the trigger, and go to cloud. Questions?
Thank you very much, Kandaswamy Umapathy. Now, Dr. Ferdinand James, Deborah Ferdinand James has joined from West Indies. I leave it to her. Dr. Deborah, please take over as the chair. Kindly introduce yourself also so that people can understand. Yes, Deborah. We are unable to hear you. You're on mute.
Thank you, Dr. Krishnan. And it's good morning here in the Caribbean, but I welcome all the participants. I am Deborah Ferdinand James. I'm a senior lecturer and coordinator of the master's program in leadership in TVET and workforce education at the School of Education, the University of the West Indies, the Mona campus in Jamaica. I will just ask Kandaswamy. My program deals a lot with leadership and training our graduates. So could you just speak briefly to your role as a leader in cross-functional teams in hosting these hybrid applications and these cloud applications? Just briefly, what are some of the challenges? What are some of the unique opportunities you have as leading these cross-functional teams?
I can split. I'm not sure. Do you have two questions or one question?
Just one. You are highly skilled in hosting these applications,
right.
in leading your cross-functional teams because you have different platforms. So what are some of the challenges or some of the takeaways, the unique things you learned that you can pass on?
Okay. Okay, there are two aspects to this, right? So one is you manage resources across the globe. That's one thing,
Okay.
right? I mean, they are under your control, and you have no issues with that because in the cloud, so the cloud kind of expands the scope, right? We have Americas, we have EMEA, we have Asia Pac and different regions, right? So we are 24/7, right? 24/7, 365 days. So Friday is a holiday for somebody, and Saturday is a holiday for somebody else. So this is the kind of trying to get the concurrence from all these customers, and try to have the maintenance schedule for them. So that's one of the biggest challenges. So one of the benefit of cloud is we are taking the maintenance away from the customers, and we are doing on their behalf. All the vendors are doing the maintenance on their behalf, right? So so the maintenance, if you're upgrading a system, right, for one customer, we used to do in the on-premise model, it takes months and months of planning, right? Right now, what we are doing is every quarter we are doing it, without disrupting the customers. The features and functions have to be agnostic of releases. When it goes from one release to another release, the features should not fail, right?
Okay, so I understand. Yeah.
So it's a big challenge on the cloud, and this requires coordination across several teams, from engineering to operations. You looked at the stack as well. So if you look at the last model, which I'm working on, is the SaaS model, right? In SaaS model, right from networking to the application, we manage it. So there is no way you can pass it on. Platform as service, we just give the platform, people develop, they have the application, and they will have to debug all those things before coming to the bottommost layer. In infrastructure as a service, you just get some hardware on the cloud, and the responsibility was also very low because they need to debug all the stack on the top before coming to the infrastructure part of it. With the SaaS offering, it's not only different functional areas, we have different stack areas. We are the full stack vendor, right? So working with the people, and working with the people across the globe, right? It's a real challenge, and the customers across the globe, right? We need to coordinate with all time zone people
I
to
would
get things
imagine,
done.
yes.
So it's a big challenge.
Thank you
It
so
really
much.
requires a
Yes.
lot of good communication and interpersonal skills.
Thank you for that very informative response. And we'll move very quickly to our next presenter. And I would briefly introduce him in the interest of time. And I believe he is Mr. Mohan. Are you there? Okay. He is the Principal Cloud Architect, Human Capital Manager, and he has extensive experience in full life implementations, including process design and re-engineering, analysis, conceptual design, and final deployment of the solution, among other skills. I am pleased to present to you Mr. Mohan to make his presentation.
Thanks a lot. Good morning, everyone, and Krishnan for bringing me here, and Kandaswamy, thanks for that wonderful presentation. So it gives some idea about what is cloud computing and what I'm going to talk. It's just a precursor to my topic, what I'm planning to do today. So I think he spoke about the cloud computing, and also he spoke something about security and data privacy. So I'm just going to talk about just data privacy, not security. Okay, so that's my topic, which I'm going to talk. So between Oracle and SAP worlds, I would think 2/3 of the data sits in our applications. Okay, so you can imagine the amount of data which is sitting in the application. And two things which we need to be very clear, right? One is security of those data, and also data privacy related to the data. So I'm going to walk you through. I know that I have limited time, so I have a lot to discuss, but I will try my best to cut as much as possible, and we will go from there. Okay, so the very first one, what I want to talk, let me just share my screen. If you're able to see my screen, just give me a thumbs up, please.
Yeah, we can see your screen. Yeah, it's correct.
Okay. Okay. I'll go on display mode, so it is large enough for everyone. Okay, so it's not sharing, right?
Yeah,
When I go on a display mode, it goes away. So,
it came out in a nice way.
yeah, I saw that. Are you able to see it fully? Is it okay?
I can see only your PPT, not in a presentation form. FI.
Okay. Is this okay now?
Yeah, it is okay.
Okay, so Kandaswamy spoke a lot about the security and privacy, right? So nowadays, the privacy is a very important concept. Everywhere you go, right? People start thinking, my data, I want it, and I want to make sure it got to be private and nobody can access that, right? So there are a lot of legislation and policies related to data privacy that's put up by many governments and many organizations. So we are going to talk about what governments, mandate these things, right? So the word what you see here, if you think like compliance is expensive, try to do non-compliance, it's more expensive, right? That penalty, what you need to go through to maintain all these, they're very expensive. Right? And almost, I believe, like they charge you almost 5% of your, I think, turnover to be the penalty for being non-compliant with data privacy. Okay, so all these things started way back in 2018 when Europe came out with GDPR. That was the starting point when they said, like, we want to make sure our data remains in Europe before anybody touches them, right? So many countries, since GDPR came in, a lot of other countries have started implementing those things. Some of the very strict data privacy rules are in Russia and also France, and California also started doing very strict compliance on these things. Okay, so these are some of the examples of privacy rules across countries. So I am out of Canada, and we do a PIPEDA, which is very strict within Canada. So they started implementing, but not to the extent of GDPR. Then Europe has got GDPR, US has got its own GDPR version of the privacy rules. And I believe India started having one recently, and they are also trying to be implementing all these things in a very strict format. China, Singapore, everybody is wanting to implement this, right? So they want to kind of make sure protect the data. And recently, like I know that the entire world was boiling when WhatsApp said we are going to implement some privacy rules, and a lot of people came out of those things, right? So that's a significance of privacy, right? So coming back to, as I told you, right? So the privacy concept can be into two forms, right? One is like, like you need to kind of go through a country legislation and also company's policy itself, right? So think about Oracle or SAP or Google or Microsoft. They all spread all over the globe, right? Like if you think about SAP, we are out of all the countries in the world. So any data which flows, we need to be compliant with the countries from which the data is originating, right? So we need to make sure all the application, what we kind of do, are in compliance with those data privacy regulation related to those countries. So think about those things, right? There are a lot of data, like every company has got a lot of data, millions of employees, right? So if you take up SAP, we do have almost like 200 million data records of people sitting in the cloud, right? So we spoke about cloud computing, and also Kandaswamy spoke about data sitting in an on-premise system. So when the data sits in the on-premise system, it's totally different. But then when it sits on a cloud version of the software, it is totally different, right? So you don't know where the data is storing. It stores in some kind of cloud somewhere in the sky. So everybody want to make sure like that's been not compromised, right? So here I'm just going to quickly run through, right, how all these things are coming across. So I mean, who are the stakeholder for all these things, right? So even though there may be a lot of people working in the organization, these are the main people who are responsible for all the data privacy. There's a governance model for them, and there's a data protection officer and operation of all these things, right? So I mean, previously nobody thought about, like we need to have a data protection team within the organization, right? So now, if you look at any larger organization, they have all these things. The governance model, more and more, I implement the solution of SAP into the customers. They all talk about data privacy, right? They talk about data security and data privacy, how the data center was secure, right? So once they have a lot of audits which are being done by third-party company to make sure the data which is sitting in there are secure. And on top of it, they're talking, okay, your data center is secure, everything is fine, but what's the privacy related to the application? That's what we're going to talk now, right? So if you're looking at these things, there are multiple people who are involved in it, right? Like controllers and processes of the data, right? Controllers who will own the data, whereas the processor may be a data entry operator who will enter those data, right? So you have to make sure like you know the difference between all these things. So what do they enter, right? Even if you take a lot of application, I do all the human resources application for SAP along with the data privacy pillar. So if you take a personal data, think about, right? You as an employee, you bring your own personal data, right? You own it. It's not company wants them, right? Your name is your own data. Your data, but you bring it. Nobody can change it. You bring in your social insurance number or social security number or any other country legislated mandated numbers, right? Those things belongs to you. Company is just using them. So when you're giving those data, it need to be protected, right? One thing, they need to be protected in a secure way, and also it need to be protected so that privacy related to that is maintained. So these are very, very sensitive data, right? These sensitive data can duplicate yourself, right? Like if I'm able to find out all this information about Uma or Kandaswamy, I can create another record of Kandaswamy or Uma and do anything with the data, right? I can get a credit card or I can do anything with those things. So when you give these data to an organization, you want to make sure like it's secure and it's private, right? So when you give these data, these are the things which need to go through. I'll explain it a little bit later also, like consent, contract, legal obligation, vital interest, public interest, legitimate interest, right? These are the things which they need to do, right? So that's what we build into the application, which is called privacy by design, right? So when we build an application, whether it's Oracle or SAP or even any small providers, they need to start looking from this angle. Are they in compliance with all these things? Are they building a solution which is going to be privacy inbuilt, right? So these are the things. I'm just going to provide a deck to Uma, like somebody want to see it, they can have a look at them. So you will understand what are those rights of the person, right? If I'm giving the data to a company, what are my rights, right? What are the company's rights? My rights are like, I need to be informed, right? As a company, I am using your social insurance number because I need so that I can process your salary, right? Then also the company need to give access to the data which is getting stored in some kind of application, right? If it's a human resources system, I need to have access to my data in the system. It's not, you should not restrict that access, right? And if I need to change the data, right? If there is a mistake in the data entry source, I need to be able to change the data to the correctness. And I should have a right to erase the data, right? And also I should restrict the processing of data. Like if they are processing my data towards, some kind of social media activity, or like if they're giving the data so that they can make some kind of decision, I can tell them, you should not be using that data. Then data portability. If they are porting the data, I should be aware of that. Yeah, right. So this is the one, auto decision profiling, all those things, anything which they're trying to do, they need to be letting me know. That's the very key concept about the privacy, right? So, and also like they need to show the compliance, right? If they're doing all these things, I want to make sure like they are in compliance. That's why the third-party audit company comes in. That's why the data governance model comes in, which they audit, make sure like all these things are in compliance. And I should feel that, okay, my data is sitting in a secure way. Okay, so coming into understanding your data. So I told you about the data, right? You as a person come with some of the data, right? Think about name, address, phone number, anything which belongs to you. That's a very personal data. And again, when it comes to personal data, there are more sensitive data also, right? Some of the people, now I see a lot of people, they don't want to kind of give their gender, right? So when I started my career journey way back in 90s, like we had only 2 genders. Now, if you take up a lot of the countries, they have 4 or 5 gender, right? Within Canada, we have 5 genders. So it's not mandatory for anybody to provide that information, right? That's sensitive to me. I don't want to provide race, all those things have become very, very sensitive. Like it can, I mean, many companies want to kind of record them, but it's up to you, right? I do still remember way back in 90s when you build a resume in India, we used to have all the sensitive personal information in the resume. Even today, when I see some resume from India, I used to see real sensitive data being published in the resume. The last column, they'll put personal data, sex, date of birth, passport number, a lot of race. These are the things which they are putting. So even though like a lot of software application has those options to be done, but now it's up to you to reveal that or not, right? I can tell the software application, you know what, I don't want to reveal all these things, right? So these are the data which you need to understand, right? So as I told you, like the personal data is very important. It belongs to you. So you manage it, not company manages them. You own it, company just takes it from you just to process certain thing. And also you should remember the concept of data minimization, right? So you just need to have a data which is required minimum to run any operation for any third-party companies or the company for which you're working. They start thinking about data minimization. I need only 2 set of data from you. That's what I want to read. I don't want anything more, right? More the data you're taking from any employee, it means that you need to start maintaining this data. You need to make sure the data is secured, and also it goes through the privacy things related to that. So as I told you, like all the application, what we do, I mean, what any big organization or any big vendors, they all have all these things, right? As I told you, consent, data, subject reporting. If somebody is taking your data, like the application should be able to make a report who is taking the data, right? The change audit, like if somebody is making any changes, I should know that. Somebody is reading your data, they should know that. All these things are reportable, right? So they're able to see, yesterday, you know what, there's an X guy who went through my personal record and saw my record. So company need to find out, hey, why did you go through this record? Is it any job related? So they can take action. And also data blocking, it's very important. So I'll talk about in the next slide, and data purge. So I remember in the olden days, in the 90s, when we started, we used to have a big room with a lot of files of all the employees. I literally started thinking, you know, what they do with this, all these paper files and paper trails of employees' records, right? So I literally, next time when I go to India, I need to go find out, are they kind of purging all those data? They're still keeping it. It's personal data of employees. So this is the data lifecycle management, right? So if you think about any data which is coming, just think about any data which is coming into the application, right? So you create the data. So when you create the data, it means that you are using that actively. And as I told you, you need to go through all the data privacy concept, whatever I explained earlier, so that it goes through and people have access to that. Once the data comes to an end, for example, you as a customer, your relationship with the vendor is done, it means the data is end of life for the data. Or you as an employee quitting the organization, it means that end of the relationship with that employment, right? So it means that the purpose for the data is coming to end. So at this stage, what company need to do? They need to start blocking the data. Nobody should have.
Excuse me, Mohan, sorry for interrupting. We have just a couple more minutes, about 3 more minutes. If you can wrap in 3 minutes, we'll be able to have the other presenters present this morning.
Yeah, I will, close it very soon, yeah. So
okay, thanks.
I mean, when the data is coming to end, like if somebody is leaving the organization, it means that you need to block the data. So there are a lot of legislations for every country, how long they can keep the data in the system. And also there are companies mandate and also some legal requirement, right, for that organization. If the employee record is going through some legal battle with an organization, then you need to have it, right? At that point, when you're blocking it, once the legislation time is done, it means that you need to destroy them. You still not have them in your system, right? So that's a data lifecycle management. So I want to walk you through the privacy by design very quickly. So these are the concepts for privacy by design. It means these are the principles which you need to embed in your application, right? So you should, it got to be proactive, not reactive. If there is any issue which is coming out of the data, you need to be making sure your application proactive, not reactive, not after the fact that there is a breach in it, right? So privacy is a default setting. You don't kind of build something, right? So you need to have that setting in the system itself, embed every design related to privacy in the system itself, full functionality of everything. So it means that, you know, you are not compromising security when you build the privacy, right? You should have full functionality. It got to be secure, and also you need to inbuild the privacy. End-to-end security, as Kandaswamy said, like lot of concept in this, right? Like security of your data center, security of the application, all those things comes in. And visibility and transparency, what I told you about how your data need to be maintained. Respect for the user, right? So you should give access to the user so that they are able to find out. These are the privacy design principle, which is being globally used by many companies. And strategy is simple, right? If you're kind of wanting to protect the data, what unlinkability is a very important thing. Control, transparency. You don't link your data to one system to another, right? It got to be sitting in one system. And also I talked about minimization, right? Minimize the data, be abstract, separate, and hide as much as possible. And you have control in in place for these things, enforce whatever you're trying to kind of do it for your private data, and also demonstrate your basically kind of controlling and enforcing, and also inform the users of the data. So yeah, I think last thing is data residency. So any large organizations, you need to make sure that data residency is very important. As I told you, Russia's Europe. Like if you're creating a data, it got to be created in their own country, right? Think about Microsoft or SAP or Oracle. They have employees all across, but then they have a headquarter in the US where they start processing the data. If you're hiring somebody from France or Germany or Europe, it means that the data need to be originated in a data center, which is in Germany or France or Russia, right? Then it can kind of replicate over to other data center. That's the data residency. And a lot of application which we have built in the recent, they all have this concept inbuilt, so that it's all there starting in the country where the data is originated. So I think, yeah, I'm almost done. Yeah, thanks a lot. Appreciate listening to this.
Thank you, Mohan, for sensitizing us to the importance of data privacy and protection in the cloud. The floor is now open. We'll take 1 or 2 questions. You can type in the chat or speak in the mic, and Mohan will respond to your comment or question.
I think no questions so far on the chat.
Okay. For students who are coming in, because the question was not responded to from the last speaker, students who are coming in new to cloud computing, how would you advise, or are there opportunities to enter the field at that level, to get into cloud computing and maybe a specialization in data protection and privacy? You're talking about novices here, students who are hearing you and are stimulated and interested. How would they get into the field?
Data privacy is a very, very sensitive information, right? Which is coming up recently, right? It came only from 2018. So I started practicing. I'm an architect for HR systems, right? So when this came in 2018, that's when I started looking into that, and I started building, privacy design concept within our application. So, there are a lot of ways people can come in, but then data privacy to come in, like, I think they need to study a lot. If they want to work in a country where they want to kind of implement, it maybe they need to understand the legislation related to that country and start implementing, right? So even though I would say I have a master's degree in law related to data privacy, but I don't practice law, right? I'm not a lawyer. I don't kind of tell the companies, what, this is what you do, right? But every company has got the legal department. They are the one who will have to tell. We are just advising them. These are the things you can do to protect, or you can, these are the things our application has to protect your data or privacy of your data, right? But then they need to implement. Companies have got their own policy. We cannot, we can be advisors, and there are a lot of opportunity, right? Like every country is like started looking into this. So every implementation, as I said, when I go implement, they are talking about data privacy, what your company can offer, what the application can offer, right? So the application, once your application is built with the privacy by design concept, it's just the implementation of those concepts into the application based on the legal requirement and also companies' policies. Yes, there is a lot of opportunity. It's a very, very upcoming field, brand new, it's just a brand new child, I would say, like 3 years old. So anybody who want to come in, it's a great opportunity. There are a lot of certification which is available for data privacy. I will start sharing Tuma, and you guys can take it from there. So a lot of opportunity, that's what I would say.
Thank you. Thank you very much, Mohan, for that very insightful presentation. Our next presenter would be Mr. Sriram. And if you can get your presentation ready. He is the lead for business development and strategy at FabHeads India. And he has worked across different technologies like metal 3D printing, polymer 3D printing, ceramic 3D printing, concrete 3D printing, and bioprinting. He has also worked on various CD printing material development projects such as binder jetting, composites 3D printing, and metal printing. So he's very highly technically skilled in 3D. I present to you Mr. Sriram, and he will speak to us on the role of additive manufacturing in Industry 4.2. Over to you, Sriram. You can share your screen.
Thank you, ma'am.
You're welcome.
Yeah, thank you so much for the opportunity. I really appreciate Dr. Krishnan Umachandran giving me an opportunity to present in this forum. Really interesting to know about the previous two presentations given by the colleagues. It was very informative. So I'll just start my presentation with a small short video which gives a glimpse of what 3D printing is and how it is revolutionizing the world. Yeah. So. If you look at we would have seen the computers and CNC machines in the past 30 to 40 years. So 3D printing is like a new range of technology that have been of range in the last 20 years. Initially, though it was only used in prototyping, now we use it in all the stages, right from prototyping till the product development. As you know, there are currently around 15 to 16 known 3D printing technologies. 3D printing is not just a single technology, but it is a branch of technologies. So depending on the materials and depending on the process, so there are different classifications of 3D printing. As you know, the raw material can be a powder, the raw material can be a wire feed, the raw material can be a resin. So any kinds of 3D printing, we kind of have it. So as you know, it is also across materials, like we can 3D print metals, ceramics, composites, so anything, any kind of materials. So I mean, I'm going to quickly touch upon a few applications. Yeah. So when you look at the defense side, I think mostly the drones and several other things can be 3D printed. The drone parts can be easily 3D printed by carbon fiber materials. And apart from that, we recently might have learned that 3D printing buildings are also possible. We know that buildings take a long lead time to complete. Using 3D printing, where they have demonstrated that it is possible to complete the entire building within days. So it can be possible within 5 to 6 days. So that is how 3D printing is automating the world. And what you're seeing currently, electric vehicles. Those are the next generation, materials in automotive. EV battery casings and EV any kinds of enclosures can be 3D printed. So that makes it lightweight and also makes it high strength. So 3D printing gives in also a lot of desired properties to the end parts. So not just this, when you take to healthcare, so you can 3D print a skin and even organs, and that can be used for transplantation. So what you're seeing is a typical application of a 3D printed food. So they replace a meat with a 3D printed alternative meat, which mimics the actual meat's texture and the taste, right? So the scientists have developed a typical bioink which replicates the meat's taste and texture. So that can be replicated using 3D printing. In this way, 3D printing is solving bigger level problems like global warming, and it contributes to the betterment of the society. Yeah, so I'll just start my presentation. I hope you guys are able to see my screen.
Yes, we are seeing Sriram.
Yeah. So as Ma'am was telling, I have been in this field for around close to 7 years, and I have worked across with different materials. Like I come from the metallurgy background, and I have worked across different materials. So my core is in material development. One interesting thing is that 3D printing paves way for new materials and new applications thereby. So I'll just focus on 2 to 3 applications wherein 3D printing is transforming the world, and also being a leader in industry 4.2. So we'll start with typical applications like that. So as Kandaswamy sir was rightly pointing out, right, like how cloud computing is enabling customization. So I would say 3D printing soft spot is actually customization and low volume production. So whenever there is like a mass customization required, I think 3D printing will be the right technology to be used. So to be put in the right words, I think if we need to move towards on-demand manufacturing, I think 3D printing is the right way to go about, along with the existing technologies like IoT, cloud computing, AI, machine learning. I think if 3D printing can be used in combination, I think every industry can benefit tenfold than it is currently. We have mostly heard a lot about the technologies mentioned, cloud computing, Internet of Things, robotics, and AI. So when we say digital fabrication, 3D printing plays a huge role with respect to digital fabrication. As you know, for 3D printing, we just require a material in digital form and a digital file. So a CAD file which will be converted into G codes and which will be fed to the 3D printer, after which the entire part will be 3D printed. So 3D printer has like 4 components. One is the hardware, second is the software, third is the material, and fourth is the printing strategy. So this will vary across different technologies. So for a powder bed system, that will have a different kind of a system architecture, and for a wire fed system, that will have a slightly different form of system architecture. So as I was telling, as the day passes, we need to identify where 3D printing is providing a huge value addition along with the conventional manufacturing, and we need to identify the applications, and we need to kind of blend that. So what I would say generally, there is actually a misunderstanding that 3D printing will replace conventional manufacturing. My answer is no. 3D printing can complement conventional manufacturing. Whenever there is a highly complex and a low volume part is required to manufacture, I think the conventional manufacturing becomes a little more of a pain. It takes a lot of lead time, it takes huge cost to make that. So instead, if 3D printing can be utilized for this soft spot, I think the industry is going to have huge benefits. So I just wanted to pick up foundry, for instance. So we have, India has huge foundries, and we all know, our throughput is the best actually compared to the other countries. Imagine if we are able to walk into a smart factory wherein the customer places the order via a centralized control system, and we have an ERP system which is actually very smart, that depending on the customer order, it identifies and it manages the supply chain accordingly. And we have a 3D printer there which is set up, and instead of pattern making itself, we have a 3D printer. The 3D printer can make metal, wood. So we have a lot of materials similar to wood. So we can make metal, wood, composite patterns that can be used. So as you know, the pattern making art is dying. So using a digital technology like 3D printing, we can even we can sustain the dying art of pattern making. So what I would say is we can use 3D printing in different levels in this value chain. You can even directly use 3D printing to fabricate low volume molds and coats. So certain molds are very complex to make. I think industry experts in foundry in this forum would agree. There are 10 core assembly, 14 core assemblies. So this require a large human skill, and also it takes a lot of lead time to make. So when these kinds of processes are automated using 3D printing, that eventually adds up a lot of value chain. There will be 30% of weight savings. There will be 50% reduction in lead time. There will be 20% reduction in the cost. So I have in past done some case studies, and it has been successful in implementing 3D printing. So as you know, the one way of looking at it is to 3D print the pattern. We can have larger machines if the pattern's part is dimensions are high, and then the sand molds can be taken out of the negative pattern, and you can carry out the casting process. Or otherwise, as I told you, we can 3D print directly the mold itself. So this is actually moving towards a tool-less manufacturing. For this, we need to make use of a technology called binder jetting, wherein a binder is jetted and there is a sand which acts as the core material. The binder jets, and using polymerization, it hardens and it kind of 3D prints the entire parts. And yeah, I think this is the most exciting application for all. So the ability to customize your food is something that that has been revolutionizing the industry. Imagine during war times, there will be no specific access to food for soldiers. So if there is an option of customizing their meal, if they want proteins, carbohydrates, fats in a specific amount, they imagine they can 3D print a bar which contains a specific percentage of all these nutrients. So that is where 3D printing is also moving towards. That is one such application. And you can customize your desserts. That is for the high high-end market, the ability to customize food. There are a lot of takers for this market. So this can be used very well in this application. And one another thing is, as I told, the problem solving aspect of 3D printing. 3D printing can exactly mimic the texture of the meat, and thereby it can be used as an alternative meat. So that is definitely one of the application that is going to revolutionize. And when it comes to healthcare, right, I think there is a bioprinting technology which can 3D print the skin, and it can 3D print the living tissues. So by 3D printing the skin, I think we are in a way letting go of letting off the animal cruelty part. So generally, we initially test the product using the animals, and then it takes 7 to 8 years of test and trials, and then we implement it on the humans. So by this way, if there is a 3-dimensional layer of skin that is done, we can test the products on this, and then can directly be given to the market. Apart from that, there are also smart wearables, wherein it can monitor, they require the biocompatibility part of it. And 3D printing has materials, high strength, high temperature materials that are biocompatible and that can be used, for the implant grade. So, so everybody, has their own, requirements. So 3D printing, what it can do is it can make personalized and customized implants. So that is one thing that 3D printing can move towards. So apart from that, there are also even in terms of pharma, there is something called 3D printing the entire drug deliveries. By this way, patients who take 15 to 20 medicines a day, they can customize their pill by having varying dosages across in the same tablet. So this will make it also oral disposable, meaning it can be easily digested by older patients, or even when it comes kids. So yeah, these are some of the aspects of it. And when it comes to future of 3D printing, what I would say is research across materials. So now at least every day, scientists are discovering applications wherein they are coming up with new and new materials that can be 3D printed. So I think recently extraterrestrial habitat 3D printing was a huge thing. So you can 3D print your habitat on Mars using the locally available materials. So that is one thing. So I think by in this way, we can explore new range of materials using 3D printing, and remote and in situ process monitoring. So while the part is being 3D printed itself, we can use a machine learning or artificial intelligence to know whether this part is actually going to be 100% defect free. So if there is going to be a defect, I think the system will automatically detect it, and it is going to kind of deem the print a failure. So this will save a lot of cost for the industry. And third thing is moving towards flexible hybrid manufacturing. So as I told earlier, 3D printing is not going to completely it's not going to be a mainstream technology wherein it is going to replace all the existing technologies, because it does not have the kind of a scale. So I think we need to leverage 3D printing in areas where it has advantages, and it needs to coexist. So for instance, there are in aerospace industries which require high buy-to-fly ratios. What the ideal way to go about is, like, we can have a near-net shape manufacturing process, like direct energy deposition process, something like that in 3D printing, and it can be integrated with the machining head, and it can finish the product and it can come out. So in the same way, if, like in a factory, if the additive manufacturing and subtractive manufacturing coexist, so that is going to also boost up the scale, right? So it is going to also address the scale problems, and it is also going to bring about the value additions. So I think that is one direction where 3D printing should move towards in the future. And multi-material printing, so different profiles of different materials. So I think when we do this, I think this is an interesting application in printed electronics. So the substrate, polymer substrate, if it can be 3D printed using a single head, and the conductive inks like silver nano inks or copper nano inks, if that can be used to make the printed circuit board part of the entire electronics, I think that is going to be a huge revolution in the electronics industry. So that can be used across semiconductor and any PCB printing and flexible
we have
substrate.
about 3 more minutes. I'm sorry to interrupt. If you can.
No, I think I'm done. I'm done. Yeah, I'm done.
Okay.
So I'm open for questions. Yeah.
Yes, please. That was a very interesting presentation.
Thank you. Thank you. Yeah.
You may type in the chat, or you can speak in your mic to ask your questions. In the meantime, I'll ask you, Sriram, if students who are interested in additive manufacturing in Industry 4.0, they wanted to have like an industry attachment, where would they come into the manufacturing company? Where would you advise that they come in? Students are hearing you and they're getting interested and they want to come in.
Yeah, so that's a very nice question. So I think we encourage a lot of students to gain awareness on 3D printing, and we offer a lot of opportunities, like as an industry or as an OEM in 3D printing. We offer a lot of internship opportunities. And to be very specific to your question, I would say 3D printing has opens up opportunities in all verticals, right from the design, right, like mechanical design. You need to design a part, and then you need to figure out which manufacturing method to use. So if you design it right from the design stage, if you have an idea that I'm going to make it design it for 3D printing, then that is actually a thought process that we are making. So right from design till the end, I would say, like, every stages 3D printing can be useful. But in terms of vertical, I would say mechanical engineers, software developers, there is a software which converts the 3D file to a 3D printable format. So I think there is a lot of research being done in software development as well. And even with respect to electronics, I think connecting the firmware and assembling it. So I think there is a huge opportunity. And as I told, I'm a metallurgist myself. So I think even in terms of material science, there is like a huge opportunity that 3D printing offers. So to get to connect all the bigger dots, I would say, graduates or students who aspire to have a career in 3D printing initially need to have a basic idea on how a 3D printer works. So if that is there, I think applying for an internship, or I think even reputed institutes conduct a lot of hands-on workshop. So I think even I have given a lot of guest lectures in colleges. So I think you can even connect to me in LinkedIn if there are any other further clarifications or any other support relating to 3D printing. So I'll be more than happy to guide people. So I think, yeah, definitely that is something what I could think of.
Thank you. Thank you for sharing so willingly. And I'm
Thank
not
you.
seeing any other questions, so we will move quickly to our next presenter, who is Miss Priya. And are you ready, Miss Priya?
Yes, yes.
Okay, you can go ahead, and I will ask Sriram to take his presentation down to stop sharing. Yes, please. So Miss Priya is an assistant professor in computer engineering and computer science at VESIT Mumbai. Her areas of interest in terms of the field include artificial intelligence, machine learning, deep learning, data mining, and software engineering. And she would speak to us on additive manufacturing in healthcare. So take it away, Ms. Priya.
Thank you. Good evening to you all. Thank you, ma'am, once again for your nice introduction. So let me share the screen and we'll start with the presentation.
Sure.
Hope my screen is visible to you.
Yes, we can see your screen. You may go ahead.
Yeah. Thank you, Sriram, sir. Actually, it was a very wonderful presentation, even for the other speakers, experts. So already Sriram sir has introduced about the 3D printing, especially in healthcare industry, which was about, so he has shown some examples like smart wearable devices, as well as with respect to dentistry industry. So the same aspects, very few concepts which I would like to present in my seminar. So here I would like to cover the basic introduction about the cloud and the additive manufacturing, how this can be applied in the healthcare industry, and how the process flow which has been used for the various applications of this additive manufacturing for medical models or for any surgical implants, etc. And what are the major application areas? And then finally, what are the various growth factors? So this is what we are going to discuss it for today. So as we know, cloud manufacturing, which is actually not a new concept, and it has been executed in various enterprises, we can say, for so many years. Maybe in a different terms, it was mentioned earlier, like grid manufacturing or agile manufacturing, etc. So basically, this cloud manufacturing, it's a concept of using the various manufacturing resources with respect to the specific domain or for the industry in a service-oriented manner over the internet. So it's basically why it has been defined that is to have a globally distributed production process with many partners. They can interconnect with each other, and thus they can make the related supply chains as a luxurious one. So here in cloud manufacturing, we can say that all the computing resources and the data storage, they all are virtual. So they may be living in large data centers around the globe. So with the user, the end users, I mean the consumers, they will be interfacing these resources via well-defined APIs. And as we know, one of the most important benefit of cloud computing or the cloud is we need to pay only for the resources that we are going to utilize it. So also along with this concept of cloud manufacturing, let us also discuss how the contribution of additive manufacturing as well. So we can consider the cloud manufacturing into two different aspects or the applications. That is, the first application, when we say that it is an industrial, it can be considered within an industrial environment. So for which the cloud manufacturing provides a concept to embed or to connect, we can say we can utilize, as well as we can utilize the existing manufacturing resources. For example, as Mr. Sriram has discussed about the 3D printers, drilling, or any other and the other machines. So the cloud manufacturing is not limited to the additive manufacturing, but additive manufacturing can be utilized within the concept of cloud manufacturing. And the second important application, it is mainly for our end users. They can use this additive manufacturing, that is in 3D printing resources over the internet instead of acquiring their own 3D printers. So it is here when we discuss that it's a usage is highly service oriented and we have the consumers as the target clients. And why and what are the various ways that it plays a role, additive manufacturing plays a role in the health industry. So when we consider the medical field, every patient case history, let us consider, that will be unique. So therefore, the additive manufacturing has a significant potential in a personalized and customized, in providing the personalized and the customized solutions. The most common we can consider as a medical, the clinical uses can be personalized implants, that is the customized implants. And the second thing, which is about creating the medical models. For example, if you consider the dental field, so where the additive manufacturing is utilized on splints, orthodontic appliances, or some dental models, etc. Even this additive manufacturing is also been explored for making the artificial tissues and organs, as Mr. Sriram has shown in this presentation, how that has been utilized in making the artificial tissues and the organs. So in medicine, we can say that in the medical field, there is a background already in the digitalization of the medical imaging, and that digitalization allows for reconstructing a 3D model. So from the patient's anatomy. So for the construction of this additive manufacturing in the health industry, so we should build such a system that should be with great flexibility and should be able to handle the complex structures as fast as possible. The responses should be fast and which should be helpful for our, as a helping aid, it should be great for our health professionals or surgeons, doctors, etc. So let us consider an example of the implant manufacture. So if you are having any image, let it be a CT scan image or a MRI or maybe ultrasound, etc. So we can build a rapid prototyping model. So what do you mean by rapid prototyping model? It is actually referring it to the group of available resources, processes. So it could be a rapid tooling or maybe rapid repairing, rapid management. It's a combination of multiple processes which can create such type of solid 3D parts from the using with the help of the CAD. So we can also say that this rapid prototyping is an additive fabrication of the parts, but with limited functionality. And we can ensure that it will provide sufficient well-defined specific characteristics. And this is another example which we have shown for this in the dental field. That is the manual manufacture, that is wax model, how that can be used to construct the implant PMMA molded model. That is it is actually being used as a substitute for the dental roots. So here the rapid prototyping, basically it has been used to speed up the creation of the prototype, that is for the software or any product prototype in any kind of product development. So we can say that a typical workflow for any personalized medical devices, it always begins with imaging. That means we need to capture the patient's geometry using some CT scan or any other 3D scanning models. And then the geometry can be utilized to design the patient-specific implants. Because as we know that every patient will have, for example, even if you consider in the dental industry, they have their different shapes and size, etc. So we need to design in such a way which should be patient-specific implants, and this design can be additively manufactured. And we can also say that it actually works, the additive manufacturing, which works as a reverse engineering process. Why? Because it's based on the doctors or the health experts diagnosis. Then we are taking the scanning images just to find out, and then we'll follow a certain process flow in order to get the final product. So here I would like to discuss about the process flow for any medical model. Any typical process or flow for such type of manufacturing medical models, it starts from the patient's anatomy, which has been captured via such type of medical imaging. And then followed by, we need to construct a 3D model using certain segmentation algorithms. And then followed by, there is a need for that is with the help of the additive manufacturing. And then finally, there should be a post-processing step. So which will help to remove the supporting structures. That is basically this post-processing or the stabilization which we do it in order to increase the strength, the security, safety, and the accuracy of the model. For example, in the dental tools or the instruments, or if you consider any dental part, here the process starts by taking an impression of this, the scanning of that particular part. That is impression of the patient's teeth, and then we are taking the 3D model, that is 3D scanning of it, followed by the 3D modeling. And then the additive manufacturing, that is here they use the batch photopolymerization additive manufacturing. And finally, the post-processing step, which will be using this part, which is made as a mold for any soft orthodontic aligners. And followed by, we can discuss about what are the major areas that was covered by additive manufacturing in healthcare. So these are the 5 major areas, that is medical model, surgical implants, surgical guides, external aids, and biomanufacturing. But one of the widely used application of such additive manufacturing model within medical field is, which is already having a big impact, is the ability to practice before procedure, that is pre-surgical planning. So we have one of the most widely used applications in the medical field is the pre-surgical planning. Along with that, even the surgeons make use of the data which is taken from any imagery applications like MRI scan in order to build the 3D models of the patient's anatomy, and then that will be that they will operate on. They can make use of this 3D CAD data to manufacture the 3D printed models and enabling them to practice the tricky surgery techniques on a realistic model in order to make it more perfect technique. So it allows the surgeons to be more precise, or they can reduce the risk, and even they can do their work, that is operate in a faster manner. So similarly, if we consider the dental industry, it is also one of the biggest users of this 3D printing. Again, they will be using scans that is taken from the actual patient's mouth, dentist, and the dental laboratories. They are able to build a more accurate and tailored solutions in order to fix any kind of dental problems. So these are the various major additive manufacturing which is being used in the dentistry. And few use cases, what we can say is the 3D printed aligners. So we slowly move the teeth into a desirable position, as well as the 3D printed crowns and the bridges for such type of implant treatment that is widely used in such case studies. Similarly, the patient-specific implants are very expensive, and if you see, they are more time-consuming if we are considering in the case of the traditional manufacturing techniques. But with the help of the additive manufacturing, it can be done very quickly and precisely in a massive reduced period of time. So this can be used in various leading applications like pre-surgical planning, as we discussed. That's about the custom planning, even for the communication between the physicians that is being used. And it is one of the powerful patient presentation tool that can be presented, and it's like they can, the health expert can be get well prepared for before they actually go into the further steps.
This is Priya. I can interrupt, sorry. If you can wrap up in just 3 minutes, that would be fine.
Pardon?
If you can wrap up your presentation, we're running out of time, yeah.
In 2 minutes. So similar way, it can be used in the custom processes design as well. That means it's a replacement of your body part. Either we can do it in an internally or in an external aspect. So this is one of the, again, we can say another famous case studies in 3D printing for medical applications. So this additive manufacturing offers the ability to make the patient specific prosthetic without being, that is in a, not in a great expensive thing, but it should be an affordable manner behind. And the various growth factors that is related with the healthcare device market is, one is the aging population. And the second thing is, we see overall around the world, the increase in the, that is a chronic disease, either it is heart attack or diabetes. So many chronic diseases, it's becoming an increasing burden everywhere. And the third thing is about the health insurance penetrations and the demand for the healthcare infrastructure, as we all have experienced, especially during the pandemic situation. So these are the certain factors that we need to have a better manufacturing or the latest techniques in the healthcare device market. So to conclude, the additive manufacturing enables not just the personalization, but also, most importantly, cost reduction and gains in success, not just of existing technologies and the materials. But as new medical specific technologies are designed and developed, 3D printing will continue to change the face even in the medical industry. So with this, I would like to conclude my session. Thank you so much for this great opportunity.
Thank you, Mrs. Priya, for that very interesting and informative presentation. We will now take 1 or 2 questions very quickly as we're running out of time from the participants. You may ask a question, open your mic, or type in the chat. Okay, in the meantime, Mrs. Priya, do you necessarily have to have a background in healthcare, or could you come into the field with, generic computer skills to get into?
Actually, yeah. So my PhD work, which is based in healthcare. So I defined IoT, that is Internet of Things based multi-layered architecture, especially for the heart patients, along with the machine learning techniques. So for the last 5 to 6 years, I'm working on this healthcare related projects. So even we are collaborating with the other industries and organizations to work such type of projects. That is how I got interested into this field.
Thank you. That's very good to know. Any other questions for Mrs. Priya? Okay, we will move to our next presenter, and if you can get ready, Mr. Prabhakaran, are you there?
Yeah, I'm there.
Okay, please start uploading your presentation while I introduce you. He is the head of Global Business Operations, Cloud and Infrastructure Services at Larsen and Toubro Infotech Limited. He's a problem solver and an able business leader with success of over 25 years of progressive and blended IT experience in almost all the areas of operational excellence, project governance, implementing change/transformation programs to include the talent lifecycle management in an organization. While he is uploading, he's currently on a professional journey to envision business and technical perspectives to develop workable solutions. I hand you over to Mr. Prabhakaran so that he can make his presentation. Over to you, sir.
Yeah, I'm struggling a bit in sharing my screen. Is my screen visible?
No, it's not just yet.
All right, let's give me a minute. Looks like there is some issue.
I think what you may have to do, if you have a PowerPoint, you need to open it and have it up on your
it's already
computer.
up.
Okay, and then
it's
just
already
click
up.
share screen at the bottom.
Yeah, I'm trying to
That's
do
a
that.
green share screen button or tab. I see you have an assistant, so I know I don't need to say anymore. Thank you for the assistance. Okay, it's sharing. Yeah, we can see it. You can put it on full screen and you're ready to go. You may proceed, sir. Yeah, we're hearing you. You may proceed. Okay. I think you are muted. We're seeing you delivering the presentation, but we're not hearing you. So you need to test your mic.
Prabhakaran sir, you are on mute.
Unmute your mic.
Am I audible now?
Yes, we're hearing you.
Is my screen visible?
We're seeing you. We just need to see your screen now.
I hope it's visible. I'm extremely sorry for the inconvenience caused. Am I audible? And
Oh, we
am I
understand. We're seeing you and
All right.
we're hearing you, so you can proceed.
All right. Okay. So I would like to actually walk you through on the topics that you're seeing on the screen. First, we'll start with why do we need to pursue a career in cloud computing, and then what are the prerequisites one has to have if you want to pursue a career in cloud computing. What are the top cloud computing careers and roles that are there in the market today? Some of the top cloud service providers who are creating waves in the circuit, plus the market trends, which is the most important thing, which actually allows us to take a decision. Plus, in case we want to choose a career in cloud computing, what should be the roadmap that you need to have? And to summarize, I'll be talking something about what is the future of this domain. So having said that, I wanted to start with one bold statement that the cloud market brims with a lot of opportunities for IT professionals, right? Having said that, so I wanted to also let you know that in this hyper connected world, people are connected to people are connected to devices are connected to devices, and that's what called as Internet of Things. When people are connected to people are connected to devices, and devices are connected to devices along with data and processes, and that's when we call it as Internet of Everything. So because of the emergence of Internet of Things and Internet of Everything today, the whole dynamics of the market has changed and extremely, especially the customers decision to purchase, the expectations, the behaviors, everything, and of course the needs have changed. So what is driving in the market today is Internet of Things, Internet of Everything, the digital enterprise solutions, and the 7 tech force, which is playing a crucial role, is network, mobility, analytics, cloud, social security, and sensor. Of course, the whole industry is moving towards 3 A's. It's automation, analytics, and artificial intelligence. So at a high level, if you're new to the industry, just want to let you know that this industry is also divided into 2 sectors. One is the products and goods, typically is of any environment that you see. So here, what we call it as products, about the hardware and software that we talk about, and the services are the IT services and the IT enabled services. Just to give us context to what we're going to talk about, and it's an industry which is evolving. Like if you see the evolution, the first generation started in 1960s with mainframes, and then in the 70s we saw the mini computers, and 80s 90s where the era of client server technology. In 2000 was the internet boom that came in, and 2010 onwards it's the digital tech stack that we are into. Similarly, the way it is, happening on the operations is also in the 1990, we used to go to the device, right? That's what we call it as YGTD. And then in 2000, bring your own device concept came in. 2013, the Internet of, things kicked in. And from 2020 onwards, we are in the era of Internet of everything. So the primary domains that you see in this, industry is one is the application development and the maintenance services, the industrial engineering services, enterprise business solutions, testings, and the infrastructure management services, the cloud and infrastructure management services is what we saw, And last but not the least, in terms of market size, is 1/3 of the global IT service market today actually belongs to the cloud and infrastructure management services space, whereas the conventional, application development and management services share comes far below the cloud and infrastructure management services space. The cloud market is today actually estimated to be around 1,025 billion by 2026. So from an opportunity perspective, in typical business parlance, $1 million can create about 30 jobs. So if you go with that mathematics, $1 billion can bring you 30K jobs. And just imagine if we go by the prediction of 1,025 billion by 2026, the amount of jobs that you'll see in this market is huge. So talking from that perspective, it gives me immense pleasure to little bit, talk about what is the cloud and infrastructure management services, who are the stakeholders, and what are the types of jobs that you see in this area, and of course, what are the opportunities that you see from a growth perspective. So for businesses to run and grow, as I said, right, today the needs, behaviors, and the expectations of our customers are changing. So if the needs, expectations, and the behaviors of the customers are changing, if they want everything at the click of a button, the way we do our business also should change, right? So for the businesses today to run and grow, IT has become essential, and the availability of IT infrastructure has become critical. So IT infrastructure is no longer about network, storage, database, or operating system for that matter. With the advent of virtualization, cloud, everything as a service, the whole scope has increased. It is a platform on which all the business applications are residing, and it's a bedrock at which the business differentiation and values are being created, right? So therefore, it's critical for all of us to focus on the usability, availability, and scalability of the IT infrastructure. And we have to, end of the day, empower the CIO to be more, like an innovation officer or a chief, information officer. And we need to enable and empower the CIO to work with equal efficacy and professionalism and proficiency. So it's the place where you see that all the action happens. That's what we call it as an exciting place, and it's a flourishing space, and it's the fastest growing segment within the IT's industry out of all the 5 domains. Majority of the top deals today, if you see from an industry perspective, are back from the cloud and infrastructure services market space, and it's very unique, and it's also called as the backbone of IT, right? It's a light on service, like how we know the impact only when there is no electricity, water, and oxygen. The absence and presence of this infrastructure is always felt, and it's very critical, and it's the only service line that grows at the rate of 30% year on year. So out of the top 10 deals won by any company, if you see today, 9 are from the cloud and infrastructure management services, and the growth that is being registered is only 8% in other areas, whereas here it is 30% if you look at the ADMS and start comparing with the IES segments. So the type of jobs that we do here, right, from an opportunity perspective, if you really want to really very keen and you want to make it big in CIS, it starts from the design, solution designing, solution implementation, production support, administration, disruptive transformation, and IT service operations automation. So this is something that you need to keep in mind if you really want to make it big in this. So I'm going to skip this because it's all covered by our Kandaswamy. So I'm not going to say anything, but if you actually see from the business perspective, from the group as a group, and we say we belong to the cloud and infrastructure management services group, what we do as a group is that we provide, solutions and services to enable our customers to plan, design, build, run, and transform their IT infrastructure, cost effectively and in an efficient manner. So that is what we do as a group. As a group, we provide solutions and services to enable our customers to, I would like to reiterate, plan, design, build, run, and transform their IT infrastructure in an efficient and cost-effective manner. So having said that, if you are into this, what is the focus? The focus will always be obviously on usability, availability, and scalability of the IT infrastructure that we have. So this is something that anyways already he has spoken in the starting itself. So I'm not going to talk much about just the models, service models and the deployment models. So we can skip this portion and move on to the prerequisites. So if you are planning to make it, into this, the inroads, then you need to be having the fundamental prerequisites or the expectations is that you come with the programming skills background. Familiarity with the databases is very critical here, because you will have to link your efforts to the databases, and the databases are the ones which manages the data. Basics of security and privacy is something that is very critical here. Knowledge of agile development, networking basics, and flexibility. So the expectations is that if you are a fresher and you're going to start something, then before you start, it's better to get some industry recognized certifications, have 3 to 6 months of internship programs on the areas of interest and domain that is going to take you, plus a strong online presence even before you could make it into the stream. Plus creating an online portfolio will be good enough for you to make the cut and know how to deal the job rejections, because it's not that always you will be able to crack at the first go. So there could be situations and scenarios where you will have to take a second chance and you may be rejected. So you need to know how to deal with the job rejection, and of course stay up with the latest trends so that you're able to channelize your efforts. These are some of the prerequisites and expectations which I would like to highlight and call it out. And moving on, next is the the top cloud computing careers and roles. Is the one which you are going to be very keen to know is there are opportunities for both the entry level graduates as well as the experienced folks. For entry level graduates, we will have roles like cloud DevOps engineer, cloud SysOps engineer, cloud security engineer, cloud data engineer, cloud apps developer, cloud automation engineer. And similarly, when you go into the experienced category, people are more preferred for the roles like architect, cloud architect, enterprise architect, DevOps expert, cloud data specialist, cloud security specialist, and cloud automation experts. So next we'll look into what are the skills that are required in case if you have to get into this, and if this is the opportunity that are there. To start off, I would like to talk about the cloud admin, which is there on the screen. So you need to have programming languages. That's one of the prerequisites here, as I said in the beginning itself, plus knowledge on tools and skills, database configuration. You should know how to handle the cloud infra systems, plus configuring the VMs, the virtual machines, and the virtual private networks, cloud servers, etc. And the average salary, and of course, this is only a ballpark figure and subject to change, which keeps changing. So at this point of time, you can land up with a job that can give you a package of 65K per annum in terms of US dollars in US, and in India it should be around 7.5 lakhs. And the company that keep hiring for these skills and for this kind of roles are the ones which you see at the bottom, which is Wipro, Infosys, Accenture, IBM, etc., to name a few. Next comes the cloud application developer. Here also the skills required are something similar to what you see with respect to the cloud admin role. The programming knowledge is a must here also, plus the database skills, understanding of the Linux operating system, which is the most widely used operating system here in this scenario, and the cloud service platforms, which are being provided by AWS, Google, and Microsoft Azure. So the average US salary is 70K per annum in terms of USD, and in India it can take you up to 8.5 lakhs per annum. And the company that keep hiring for the skills is Bosch, McAfee, SAP, etc. The third one is the network engineer, cloud network engineer. The skills obviously required will be the knowledge of networking protocols, cloud security protocols, data center administration, cloud computing platforms, AWS, Google, Azure, to name a few. And of course, the salary, what you see is on the screen, is the average one in US will be around 72K per annum. And India, it could be around 5 lakhs per annum. The companies keep, keep hiring these skills, and these, roles are AWS, Rakuten, Cisco, etc. So next, in the interest of time, I'll be moving.
I have to interrupt and ask if you can wrap up in just 1 minute. We are running out of time.
I understood. That's what I was about to give a heads up, stating that I'll be quickly winding up. These are the remaining four roles which I wanted to talk about: the cloud automation, security manager, cloud engineer, and the cloud architect. I'm not going to go deep and explain you, But more or less, if you look at the skills that are required as the programming languages, plus the DevOps tools and the database knowledge, and of course the cloud computing services, and the salary ranges are what you see on the screen, and the companies that hire are also there on the screen. So this presentation is available. You can have a look at it and have a reference, and this is only for reference. And the subject, the salary details that are provided here are subject to last minute changes. So some of the cloud service providers that you need to know today are these, what you see on the screen, in case if you want to make it into the cloud computing space. Then AWS, Azure, Google are the top 3 key players, and the remaining are the ones that you see on the screen. The market is something that is very important for all of us to know. As I told at the beginning, the US, the global market is expected to be at 1,025 billion by 2026, and the rate at which it is growing is 18%. The compounded annual growth rate is what I want to call it out. It's computed between 2019 to 2027. So these are some of the market size and opportunities that are available. You can go through this in detail. And today, if you ask me what is happening in the industry with respect to trending technology, especially in cloud, heavy investment is happening in providing solution offerings related to cloud to grab more business. So this is a place to go for all of you. On an average, 100 plus existing people are getting groomed on new technologies that are evolving every quarter, so that our existing force is upskilled and cross-skilled and of course reskilled to take up the global opportunities that are coming up, which are in the pipeline, and creating awareness among working professionals and ask them to do certifications. While this is happening, it is obvious that definitely there is a demand, and then if you are aspiring to move in, this is the time to move in. The technology keeps changing, and resources needed to adapt to for the changes, and that's the reason we are in with this. Hiring engineering graduates is happening and providing exhaustive training for 6 months to be ready for the job. So that is how it is. I'll skip this portion in the interest of time, and quickly I'll move on to the last segment, which is a roadmap, which is very important for you in case if you're choosing the scope. So you need to be very strong in the fundamentals. So I would recommend and suggest you to take up the fundamentals course first, then move on to the operating system architecture. Then the third step should be towards the programming languages which are needed, and fourth one should be the awareness and knowledge on the platforms which you talked about. Then move on to the business management skills, then the DevOps tools, and last the certifications will take you to the desired opening, and you can start in a big way. So the future is about 3 A's which you talked about. One is the automation, analytics, and the artificial intelligence. We spoke about the cloud market. The spending is about 3.8 billion by the year 2025. So heavy investment is going on, and this is given by the agency called IDC. And if you look at the number of devices that are connected to, it is around 50 billion, which was estimated by 2020, and you can see at what rate it is growing. And only 10% of world data is there on IoT, and only 1% of the devices are connected actually. So there are a lot of opportunities that are there in this space, and the digital enterprise solutions is also actually booming. In the fourth platform on cognitive solutions, automation, and intelligent agile solutions are coming up. So whatever maybe your ambitions are, but you need the right infrastructure to fully exploit the potential. So this is the way that you need to go. And last tip is that there is higher demand for cloud professionals, and it will continue to grow. A recent report said the deployment of public cloud computing system can add around $100 billion to the Indian economy and can generate 2.5 lakh direct jobs by 2023. These are the reports that are actually published in various sites in the internet. You can go and pick it up. Sky is the only limit for cloud computing. It was there in the past, it is there in the present, it will be there in the future also. Better chances for getting shortlisted for an interview is if you actually carry a course that will take you and adapt to the change and keep learning, so that your job is going to be secure. So flexibility in resource utilization, cost effectiveness, lower risk, data integrity and security, streamlined collaboration. These are some of the reasons that actually consolidate the cloud adoption trend and thus make cloud engineering a sort of a career. So that's my last statement. With that, I'm open for questions. Back to you.
Thank you,
Debra.
sir. I think it was a very attractive presentation in terms of the scope of opportunity. I already saw a question from one of my graduate students at the University of the West Indies in relation to scholarships.
Sorry, I was actually not to connect. I was not able to connect at the beginning. There was some glitch on the audio and video.
What I'd like to say to the student who has asked about the scholarships for studying cloud computing. The University of the West Indies has opportunities for graduate scholarships, and the graduate students can then decide what they'd want to study. So I can pass on that information once we finish the webinar.
Absolutely, absolutely.
Any
I'll be more
other?
than
Yeah. Any other
glad to.
questions for the presenter at this point? Okay, so we want to thank you, sir, for that insightful and attractive presentation. And
Thank you
last
so
but
much.
not
It's my pleasure, and I would like to thank Dr. Krishnan and the organizing committee for giving me an opportunity.
You're very welcome. And yeah, we did enjoy your presentation, as the others. And last but not least, we would now have Dr. Krishnan, who would be our last presenter. He needs no introduction. He has over 30 years experience in industry. He has held various managerial positions. He's currently the general manager of Nelcast India. And in the interest of time, I will hand you over to him to make his presentation.
Thank you, Dr. Deborah. I hope you're seeing my presentation.
Yes, we are, and we are hearing you clearly.
Right. Let me get into more practicality to additive manufacturing than to what textbooks and things give. See, additive manufacturing is one. Its name itself tells you it is an addition to the material. So here, manufacturing normally is a subtractive aspect. You take a metal and then you get to curve it or shape it. Whereas an additive, you take powders of it and you join it together. That is where the difference comes. This is a disruptive manufacturing process. This process is not existing. This is the one which has now come new. So you are going from the grit and grains to add together, and then you create a product. Whereas in other things, you keep on shaping, you remove material. So this is for adding material and not for removing material. So this is a different concept on which all engineers throughout the world are getting onto. So this is as good as a baby, which is forming itself into its evolution. So now when it comes to manufacturing, it has something called discrete, or it is a process. So even if it's a discrete or a process, the sustainability of the goal is more important. To create a kind of a sustainability, you need to have a collaborative design. So here you need to know the whole sum of the product. Then you go on automating it. Then you go in for a process resilience so that the process takes care of all of its vulnerabilities. Then you have the waste reduction, reuse, and recovery. This is the concept on which the total additive manufacturing stays on. You know why? Because we want to achieve a better cost. We want to have our product being reached across the world and it's available to everyone. It is taken care of the environmental impacts. And to become integrated, what you need to have a special pathway. That is what cloud offers. Cloud, internet, which we don't see, is the one which takes our data and it spreads to all the manufacturing inlets. These manufacturing inlets pick up this data and they feed it to the machine so that the machine does the additive part of its integration and it gets the product out of you get the product out of the machine. So if you want to get it, what happens is you're going to see a lot of changes in the scenario. Earlier, it was production technology. You require people and you need to have an infrastructure and you get the product. Then over a period of time, what happened was people wanted to have more products, mass production, batch production. This is where you got into the process similarities. You had a role alignment within the people. Then you had the flexible overhead investments, and then you had the hybrid or non-hybrid constructions. But now what is required is laser sintering. Laser sintering is laser, it is spick and span to a precise kind of a manufacturing. Sintering is joining all the powder metallurgy. The powder form of metals or materials are being joined together. This is the aspect of additive manufacturing. For this, you need to have people not within a core specialization, but with a different kind of a specialization where they can consult, they can perform, they can optimize, So it's learn, unlearn, relearn, and do. So it's always you need to have a kind of a people who are bubbling enough to get to know and perform. So there is a lot of vulnerability towards doing mistakes, but we learn out of mistakes. So laser sintering is a very high level of production technology methods, where when it comes to these kind of machines, what happens is every time we cannot own, at times we can lease, or we can lease and use. So the thing is, you don't go get a machine, but you buy, get into a machine when you require it. So you can go for ordered batch size productions, and then your original equipment manufacturers can have, or component manufacturers can have, or they can collaborate together and use it on a leased term. So the scenario itself is changing for a machine, additive manufacturing. So you need not worry. You want to have a machine, you can lease it and use it and give it. So it's going on a specialization. So manufacturing has changed its style. So these are the basement methods. You have a lot of critical advancements. Data visualization. You need to understand the data, and then you have to go in for digitalization, and then you have to finally get on your operational or business process. So this chart you can see. Anyhow, I'm sharing it through the video. You can clip it out and you can understand it. So more important is data. The basic is being open to everyone. It means it is transparent. When it comes to transparency, what happens is people take the data for a ride. They take they don't see the importance of it. They just take it, copy, cut, paste, and use it. See, this is where the IT has gone out, and the emerging technologies or the industry 4.0 requires not specializations but collaborative actions. We require people to join together and do it, rather than to do a specific coding or process of production and testing and all the stuff. See, this is inclusion of people with knowing IT or not knowing IT, but you can group them together and deliver. See, here, the most important aspect is the hyper-connected value drivers. Earlier, what we had was manufacturing as one segment, and then after you manufacture, you supply that to the market. But then this manufacturing and supply is being changed not only from production and distribution aspect, but through a collaborate of data applications across boundaries. So when you take across boundaries, the whole world is yours. You're not going to do a domestic kind of a production or sales, but you're going to involve the whole world together. If you want to have this kind of a thing, what happens is the tools and applications what you use, and for building and scaling up your deliverables, you need to have a good technology and the institutional enabler. This enabler comes when you identify the resources, all M's, man, machine, materials, methods, your money, market, management, whatever it is, should be of a high value opportunity. You should not think in a lower, very closed kind of a thinking. See, this is going to be useful all. And when you want to have such kind of imperative manufacturing styles, then you need to have an open-mindedness towards getting into it. This is where the data excellence framework helps you as a value driver to the manufacturing. As we go further, what happens is Industry 4.0 is the one which has taken care of all these technologies, be it simulation or cloud computing or AR or VR or big data or robotics or whatever it is. All these technologies in Industry 4.0 are collaborative. You should know how to use it. If you can use it together, then the phenomenal reach what we can gain out of manufacturing is completely different, and it is not existing. For this, what we want to have is workers, mass customizations, consumer demands, and non-standard products. So you don't do anything which is an all fit all. You can go for fit in each, customized. So by this, you are not going to lose your labor cost. You're not going to lose on your assets which you have, and it also takes care of your depreciation, because these are the aspects which are completely affecting your manufacturing strategies. For this, what you need to do is your improvement in product, your product value additions, your value addition to the market, consumer or customer, the quality with which you deliver, it is going to be completely adhered. Your QC and your QA are all completely packed. So there's no change in the value you're going to give it through your product. And customization, which is the key for this manufacturing process. It helps you in your change over time, so you can quickly change. You can run over your downtime. You can increase your reliability. You can reduce your inventory. So you can do as the order comes and you can deliver. As this happens, what happens? I mean, the biggest transformation is your organization's processes are completely changed. You can be either interested or fully automated also, or uninterested. Normally what happens is when any change happens in an industry, people are uninterested because they think what they are doing is right. But emerging technology is one which is disrupting the way how things are existing today, because the evaluated impact is on virtualization. At any point from your home or anywhere else, you can control your manufacturing. You can continuously value add on your value chain by bringing in more people and experts to contribute to it. Then you disrupt it. See, always there is a change is a continuous process. Change cannot be permanent. And then the resource efficiency, you can keep on building it and then take on to your policy, including your climate change. As this happens, then what happens is the output, what you get from the machines or your organization is completely oriented towards technologies with digital twin. Digital twin means what you change in your computer happens, reflects as a physical change in your machines or product, and what you change there in your machine completely changes on your system. So you have a symbiotic relationship between the data and the physical output, which is where additive manufacturing comes. And I will also share you how it happens as we go further in those screens. See, it takes care of the digital resources and the environment. Now the landscape. See, everywhere in a manufacturing shop, you will have machines, people, power, water, and many resources being used, right? But these are also going to be used in additive manufacturing, but in a different way. So you're not going to do anything on a batch power process, but you can also do on a small part. Even if one part is required and there is an order, you can take care of it. If it is of smaller numbers, you can take. Even if there is a fluctuation in your orders, you can take. But in manufacturing, existing process manufacturing or product manufacturing organizations, getting onto a change in the product lines or process lines is always a difficulty. Here, why it is easy? Because you have a CAD program. You have a program which is visioning the design data set. Whatever you do on a CAD, the design table, you can capture the data and then you can scan it on a real time and you can simulate it and get it out. So you can see it even before you manufacture. You can test it even before you manufacture. So it gives you a lot of opportunity. Whereas in a physical manufacturing setup, it is not possible. You only do it and then you do a destruction, or you do a testing, or you scan it, or you do your quality controls. Then only you can understand. Whereas here, even before you venture into it, you can finalize it, because this is a new gen hobbyist kind of a production. It's not only engineers do manufacturing, it's people who are interested can do it. So the cost of manufacturing cuts. Personalizing and design products are happening. Here, what happens is when people all join with a passion, they don't demand many things in the output. They are willing to give and they make an evolution of it. That's where the landscape has become an inclusive landscape. And then the advantages. See, here in additive manufacturing, we have 3 types. One is you create, you test, and then engage with it. If you want to create, what happens is you need to have an object, because this object can also be done by a traditional process. Then what happens is if your traditional process has a difficulty and in manufacturing or cumbersome or a difficulty in planning and time consuming, then you can pick that product for additive manufacturing. When you want to design, test, you can design with imagination. So this can come, new features can be added. Then when you think about it, you are always attached to expensive tooling. But then here in additive, dimensional adherence can be done, because you can see, you can visualize whatever you want to do can be seen on a picture, and you can do a simulation and then start it. Then the engagement part, the last is where individuals and communities are involved rather than experts, and the sustainable resource management, because that is the part on which any business can come. This is where the individuals and go on for a conservational efforts towards this manufacturing styles. See, already speakers before me have already told what is cloud, what is fog, what is edge, but just touching upon it, cloud is nothing but a pathway, which is from a far distant server. Edge is on your machine. You have all the computing parts, whereas in a fog, which is in between cloud and fog, edge, which is called as fog. See, all these things are connected with your IoTs, big data. Your cloud is required for as a pathway, and then augmented reality or virtual reality supports to visualize how things can be done, because it's a web-based kind of a source that is being exploited for data visualizations. See, this is completely on a software to, that is the cyber part, to a physical part. Coming on to the use. See, cloud is always required for additive manufacturing because it is safe, simple, secure, scalable, and all those aspects. And we have cloud in three forms. One, SaaS, your software as a service, or platform as a service, or infrastructure as a service. So you can lease, use, and then keep away. So you need not worry about owning it and keeping your investments on it. So you have the flexibility, like what Kandaswamy said, it can be multi or poly or hybrid or whatever models on which you can have your manufacturing passed on to. So now coming on to the additive manufacturing. There are many kinds of additive manufacturing happening, like optical fabrication. Glass is used for fabricating, glass to glass. You wouldn't see much in your real life, but this is possible in additive manufacturing. Photo solidification. You create a kind of a photo and then you create that kind of a material joining so that you get the product as per your photo. This is called the photo solidification. Then fused deposition. This is completely sintering process where you fuse it, where even Sriram showed how a core is manufactured in a foundry. Then material extrusion, you get a hot or in a different temperature material, then you force it through and you get the output. Then photopolymerization, you join it from the basics and you create it. Then powder bed fusion, you push it to get our output. Or jetting, in a finer part, you create it and blow it and get it. Or lamination, sheeting, then the energy deposition. Like this, there are many kinds of process evolution that is happening through additive manufacturing. I will touch two of those in reality. This is the one which is called as photo solidification. Photo solidification, already Priya was explaining you on the dentures. If you want to have a false teeth, you create what you do, you can get a cavity and then do it. Instead of getting a cavity, you get first a CAD diagram. You create a diagram and then you get into this photo solidification. The second slide after the computer, if you see in the picture, it has a porous kind of a porosity sheet. It means there is it divides. The above part is empty and below the porous part, you can get the liquid material available. This liquid material is seen in the third part. See, above this porous part, you have a gun, which is called a laser gun. It is connected with your computer. Whatever diagram you have created in your computer, accordingly, your laser heats up the material, base material. As the base material gets weakened or solidified, it erupts out of the porous plate. As it erupts out, you see the fourth part. There is above the porous plate, you see a kind of a product evolving. See, once you get it to the right height, then you stop it, then you cut it off, and then you can do it. This kind of a process, you don't get it in a normal manufacturing process. You cannot deliver it. This is where the novelty comes. It's a photo solidification. As per your photo, you can solid your base metal and get it out, and then you use it. So this is from a perforated base, you make the liquid pre-polymer, which comes out through this, and then you have an iterative kind of an exposure, where it requires more height, more thickness, accordingly, you can do the depth of solidification and do it. This is one step which is in offer. And the next one is your fused deposition, like how we do photocopying. What we do in a photocopier, we keep a paper and then it copies whatever we kept as the input. Similarly, fused deposition is it takes up geometrically complex shapes, and whatever it can be, dimensional, having stability or tolerance or whatever it is, you can bring those kind of materials which can form themselves as a product and used in aerospace or automotive or medical or any commercial things. Here what happens is, you see from the last slide, last 3 slides, you have a outer heater coil. It means the outer heater coil heats your polymer or your material. As this material gets heated up, what happens is it is available for being blown. When you can blow it, you can fuse it together and then get into complex shapes. You see the second one in a photo from the left, the ejecting part. And now you see the component, how it is being formed. These kind of components, you cannot do it in a normal manufacturing setup, where you will lose a lot of materials, because if in normal manufacturing, we do a subtractive material. We remove materials. If you do this kind of a thing in our normal manufacturing, you lose a lot of materials and your waste will be more than your original product. So these kind of things come out through fused deposition. Okay, it will be more technical if I touch more, many of these things. For now, what I'll do, it helps, additive manufacturing helps you in shorter shelf life products to be made. It understands the complexity. It is good for your smart products and services. It helps you in quicker decision making and rapid data and feed of the data. It is used through IoTs or industrial IoTs or cloud or whatever it is. It helps finally to go in for the need that can be satisfied at a shorter expectational times. Here comes the real design. The proxy monitoring can be done. You can do, many people can watch what is happening. It can take care of complex dimensions. It can take off unimaginable design realizations. It can give you a high quality production because it is going to take a minimum space, lesser inventory. It has a lot of automated process flow, and it's a new age factory where this R&D is for only upgrading. You can customize it to anything, and you can do a auto self-diagnostic and regenerative option. So at any time, you can think, you can throw, you can again recreate, you can keep on working on it. So it is more creative. If you want to do this, we know across the world, US always leads. When US takes up, there's a global manufacturing competitive index, and they have identified around 10. And in the top 2, you see predictive analytics and smart kind of a IoT kind of a relationship, which is in the manufacturing segment, along with additive manufacturing, taking up a bigger sphere of innovation and being accepted. As we do this, why we have to get into additive manufacturing? See, consumer is the final person who has to be satisfied. If you can give better, quality, quantity, and cost effective, then means product can reach the consumer. Once the end using part is happy with it, then any kind of a technology is required. To be with this, what happens is we have to overcome our manufacturing setup, which is always repetitive, through robots, sensors to do identify the right input and output, and ambidexterity, because you don't require more people, but an efficient machine to do it. So all these automations hypothetically give an additional technical proficiency compared to the past. This is where the automated process, it does not go with the core. The core is being eliminated and the non-value addition is eliminated, and you get a new process on evolution. This is where the new roles already, Prabhakaran has explained more on this. So there's a connectivity between software, hardware, and the enablers, along with the wireless technology, simulators, and then the creation of the products that is required. This is the new role that is required. You need not be an expert, but if you can think and deliver creative, you have a better position in the future market. Finally, These are what is OGLE and all the stuff. Up to this, I stop. If there is any questions, I'm open to it. Thank you, Deborah.
You're most welcome, Dr. Krishnan. And the floor is now open. You may ask Dr. Krishnan any questions on his presentation. In the meantime, Dr. Krishnan, I'll ask you, how does artificial intelligence inform the additive manufacturing processes that you just highlighted?
Yeah. See, artificial intelligence, again, if you want to understand, it's a combination of your big data. It has an algorithm. It has a decision-making process based on your past experience. And then you combine together in a materialistic requirement. It is not a human intelligence. It is a machine-based intelligence. Machines can do right things provided they have the right data and the right algorithm on which it can be fixtured. If these things can be done, then the output is also having a reliable acceptance for its evolution. This is where AI comes. AI is, it overcomes the human intelligence by repetitive processing of data through algorithm.
Okay, thank you very much. Okay, I'm not seeing any further questions. Nothing in the chat.
So if they have anything, they can write to us. No issues.
Sure.
Or through you.
Yes, sure. So at this point, I'd like to extend sincere thanks to our presenters for sharing their industry experience and expertise with us in gaining a deeper understanding of the current developments and opportunities in cloud-enabled additive manufacturing. Many thanks to you, our participants, and in particular our students, for your feedback and questions in today's workshop. We hope it has been a rewarding experience for you in stimulating your interest in this area and in the topic. And we look forward to you joining us for our another World Resource webinar series of workshops. Just to remind you, your participation certificates will be sent automatically after the webinar. And so we just thank you for your continued support, both from the presenters and the participants. And we wish you a wonderful week ahead.
Thank you. Thank you.
You're welcome. I now bring the webinar to a close.
Thank you. Thank you very much.